Where's my, oh yeah. Hello and good day, Algebra. Moving on to PO6, which really is a nice review of stuff we definitely did last year. If you think back to pre-algebra 18, 19, 20, no doubt you all have your binders from last year. You can look back. But it's solving one-step equations and two-step equations. Mrs. Feynman did the railroad tracks with you. That's kind of what this is here. Okay, yeah, we can do that, right? We call it opposite operations because I'm not nearly as creative or as fun as she is. But essentially, what the quote-unquote railroad tracks method is you are using opposite operations. So Annika, I'm going to draw my tracks in here, but tell me what my first step would be in solving this equation for n. Well, if we wanted to know...
Wait, never mind. You do subtract 11 from 11. So just do minus 11 and then minus 11 from...
Yes, we would subtract 11 from both sides, right? And that's why... Okay, now we're done. And that's why it's called opposite operations, because what are we doing to the negative 8n? We're adding 11. In order to get n by itself, we need to do the opposite of that. We have to undo what's being done, right? So subtract 11 from both sides. Over here, it equals 0, 11 minus 11, and we're left with that negative 8n. Why do we have to subtract 11 from the right side as well? Gum wrappers away. Let's take out the binder. Let's focus on what is going on here. Why do we subtract 11 from the right side as well, John?
Because after the 8, there's like whatever that n, and those ones don't have that n. They're both the same.
Right. We wouldn't subtract 11 from negative 8n because they're not like terms. But why do we have to subtract 11 from the negative 21 as well? We already did it from the left side. Why do we also have to do it to the right side? What does the equal sign mean? It means they're equal. Well, yeah, but more than that. John? Okay. When two sides, when you have an equation, right, those two sides are equal or balanced. Maybe in science class you've used a contraption that looks kind of like this. Okay. Ooh. But it's like a balanced scale, right? If we only subtract 11 from one side of this balanced scale, what's going to happen to it? It's not going to be balanced anymore. Okay? To keep this equation true, to keep these two sides equal, what we do to one side, we have to do to the other. It's like the math golden rule commandment. What thou dost do to one side, thou must dost do to the other, or something like that. Yeah.
So you're playing a game of hangman on the top right corner.
No, that's a science balance scale. Is my artwork not crystal clear to you? Okay. So negative 21 minus 11 gives us negative 32. We can still say these two sides are equal because we've kept them balanced. What's our second step here? What's our second step? If you put negative 10, that's just review negative numbers when you add and subtract. On negative 21, we're going left 11, further away from 0, right? That's going to bring us to negative 32. Sasha? Divide by what? Divide both sides by what number? By negative 8, right? Because what does that do when we have negative 8 n's and we divide by negative 8? The answer is positive, and in fact, what is negative 8 divided by negative 8? Positive what? Positive 1, right? Meaning that we have 1 n left, which is what we want. We don't have to write the 1, okay? When we have a coefficient of 1, it's optional to write it. But then on the right side, as Maggie said, negative 32 divided by negative 8 equals 4. So what this is saying is that, the original equation said negative 8 of whatever n is. We have negative 8 of them. Add 11 to that, we get negative 21. We've undone the equation to say that one of those n's is equal to 4. Okay? And like we've talked about before, the beauty of math, unlike science class, where if you're asked to define a mitochondria, is that a science word? help me, I don't know, mitochondria, right? You can't like define it and then check your answer by looking in your book or Googling it, right? That would be called cheating. In math, you can check your answer and we encourage it. How would you check your answer here to make sure that n does indeed equal 4? Right. Take that 4, plug it back into the original equation, and say, does negative 8 times 4 plus 11 equal negative 21? It takes seconds to do on a calculator, and it's a great way to verify you've gotten a question right, in case you make a silly mental math mistake or you miss a sign or whatever. Okay? Negative 8 times 4, negative 32, plus 11 brings us to negative 21. Okay? So basically, a quick review of solving two-step equations like we did last year. Okay? Let's look at the third one here, because ones like this tend to throw people for a little bit of a loop. N divided by 5 minus 6.5 equals negative 4.5. Draw the railroad tracks if you want to. There they are. Very, very nice. What's our first step? Connor? Add 6.5 to both sides. Okay? And if you're sitting there thinking, well, gosh, I don't know what negative 4.5 plus 6.5 is. Remember, we can reverse the order of those as long as we keep the signs the same. Negative 4.5 plus 6.5 is the same thing as positive 6.5 minus 4.5, which might be a little bit easier to do in your head. They mean the same thing. Okay? And what do we get? What is negative 4.5 plus 6.5? In 2. Okay? So now we have n divided by 5 equals 2. What would our next step be? Yifan? Excellent. Don't be thrown off by the fact that this is a fraction. Okay? It's the operation of division. So n divided by 5, undoing that means we're multiplying by 5, and n equals 10. Okay? Check that, plug it back in. 10 divided by 5 is 2, minus 6.5 gives us negative 4.5. Okay? I'm going to give you about 2 minutes to do the other two in this row on your own. I'm going to pause the video so we don't have that lousy dead air, and we'll come back in 2 minutes. Okay, spend some time working on the second and fourth one. What did you get as an answer for the second one? Who's bold enough to share? Connor? N does equal 20. Your first step would be to subtract 17 from both sides. That gives you 3n equals 60. Then dividing both sides by 3, because we don't care what 3 n's are, right? 3 n's equals 60. Great, we want to know what 1 n is. So we divide by 3, and we get a value of 20, which is correct. Aiden?
Couldn't you just like do this one the easy way where you just minus 17 and that's the
Yeah, some of these are set up with pretty friendly numbers to do it mentally. However, like we talked about last year, and some of you fell into this trap, if we only practice doing it mentally, when we eventually get to equations that we can't do mentally, look at PO7. If you don't have that process to fall back on, then you're stuck, right? Then you're left guessing and checking in a calculator, and if the answer is a fraction or a decimal, then good luck guessing negative 3/7 as what you're going to plug in. So if you can do it mentally, that's awesome. But I also want you to understand the process, right? So that when we can't do it mentally, then we have that something to fall back on, okay? The fourth one here, what did you come up with for this one? Lauren? 66. 66 divided by negative 6 is negative 11. Subtract 4 from that, you do get negative 15. Your steps here, add 4 to both sides. So we get n divided by negative 6 equals negative 11. Since we're dividing n by negative 6, we're now going to multiply by negative 6. And that gives us a positive 66 as a value for n. Okay? Maybe that one. Maybe that's one that you can't do mentally. The numbers aren't quite as friendly. You need to understand the process to do it also. Okay? Questions on those? Okay, as much fun as that is, we are going on to something even better, and that is writing our own equations. The nemesis of so many math students, if it's not fractions, it's word problems, right? Because you have to set the equation up yourself. You have to understand what operations are being involved, what order to put things in, what does this mean, what does that mean? And so we're going to kind of practice this. We're going to practice identifying a variable, a coefficient, and a constant, and then putting it all together. Okay. So who can tell me, and you can pick any of these three here, what is a variable, what is a coefficient, what is a constant? Anybody have any idea about any of those three? We've already talked about variables here, so that one, Annika.
A variable is a symbol, usually a letter, that represents an unknown value.
Okay. It is usually a letter. It is an unknown. Okay. And oftentimes, it's what we're solving for. Okay. It can change, right? If you're testing something, it's what you're able to change. Well, what happens if I do this? Or what if this happens? Or what if I do this, right? In an equation like we were just doing up above there, it's what our answer was. It's what we were solving for. Okay, so it kind of depends on what context you're using it in, but it's an unknown thing. How about coefficient? How about constant? Any ideas? Okay, a coefficient comes before the variable, and it tells us how many of the variable we have. Okay, it comes before the variable, and it tells us how many we have. In a word problem, you can oftentimes identify the coefficient and the variable by looking for the words per, each, or every. Okay, you see the words per, each, or every, that's going to connect you the variable and the coefficient. Yeah?
What's the word under us?
Clearly it's variable, or unclearly it's variable. Tell us how many of the variable we have. Yeah, that doesn't look like variable. I'm sorry. Okay. Okay. And the constant. What is constant? Right? The constant is added or subtracted from the variable term. And you can think about it as what you start with. When you're identifying what a constant is in an equation, it's what you start with. It's not affected by the variable. And you'll see what I mean by that when we go through these examples here. So it's added or subtracted from the variable term, and it's what you start with. So the first example here, it says you sign up to help a charity with preserving the rainforest. Noble of you. They ask for $20 up front, and then you will give $2 per month after that. Write the equation. How much money will you have given after 6 months, after 8 months, after 2 years? So we have the variable, we have the coefficient, and we have the constant. In this situation, who can identify any of these three things? John.
The variable is the $2.
Not the $2, because remember the variable is kind of what can change. The $2 per month, that's a pretty that's a continuous rate, right? It's not going to go up one month and down the next month. It's a consistent $2 per month. But take a look at the question. It says, how much money will you have given after 6 months? How about 8 months? How about 2 years? What are we testing here, Connor? The months, right? The length of time, okay? So for a variable, we can use m for months, and even though our last value is given to us in years there, we can easily convert that to be months. So what's changing, what we're testing, is the length of time that we're contributing to this charity. How about the coefficient? How about the coefficient? Kind of two things left. We have the 20 and we have the 2. Which one's the constant? Which one's the coefficient? Lauren. 2 is the coefficient, right? We see that word per there. I said that was kind of a really big hint. It kind of connects your coefficient with the variable. We're giving $2 per month. And then our constant, what we start with. You know, they ask for $20 up front, and you're going to pay $20 whether you're contributing for 1 month or for the rest of your life, right? It's an upfront cost. It's not affected by the variable. It's what you start with. That is going to be your constant. So putting this all together now, how can we arrange this so that it's going to tell us how much money in total we've given to this charity? What operations are we going to be using? What order is this going to be in? How can you use these 3 things to calculate how much money you'll have given to this charity after a specified length of time? Well, when you sign up, you're already giving 20, right? So that's already spent. And then what are you adding to that? Yes, in the very back. Yes, good. Adding $2 per month, right? Or 2M, okay? $20 up front plus $2 per month. And then that 2M, that total is going to change depending on how long you're contributing money, right? First, we'll test it for 6 months, then 8 months, then 24 months, okay? You can also write this as 2M plus 20, because with addition, subtraction, doesn't matter what order things are added or subtracted as long as the signs stay the same. A positive 20 and a positive 2M can be reversed. Positive 2M, positive 20, it's going to be the same thing, right? And the reason why, if you think back to last year's slope-intercept form, the reason why I wrote it this way here is because that's in slope-intercept form, right? But we'll get to that later on. So if we, just a minute. All right, anyway, so if we want to know how much we've given after 6 months, I'll erase this here. We'll use the original equation that we wrote. It's going to be 20 plus 2 times 6, which brings us to what? What is 20 plus 2 times 6? Yeah. 32, right? Order of operations, multiply first, 2 times 6 is 12, add that on to the 20 we gave up front, $32 in all, okay? How about 8 months? Our 20 doesn't change, right? That was the upfront cost, that's our constant. But now we're giving $2 for a length of 8 months. So that's going to increase the total that we've given to this charity. Lauren? 36. 2 times 8 is 16, plus 20 gives us 36. Okay. And then lastly, 2 years. I mentioned earlier we'd be testing 24 also. Since our variable is in months, we would have to convert that 2 years to be 24 months. And after 2 years, how much have we contributed? Make it be. I think you may have added first and then multiplied. What'd you say, Sasha? $68. I mean, they'll definitely appreciate your large donation there, but a little bit extra. Okay. Questions on that process? Okay. For tomorrow, I want you to do one thing. You know those memes and GIFs you've seen where it's like they had one job, right? I'm giving you one job. That is the next one. That's it.
That's our homework.
Homework tomorrow. You have one job. Do the next one. If you want to throw in some practice work and some Khan Academy and things like that, feel free. But for tomorrow, for homework, you've got one job. Do the next one. Identify, folks, identify the variable, the coefficient, and the constant. Set it up like we did here, okay? I don't want just an answer, right? I want you to identify each thing, set it up like we did here. That's homework for tomorrow. That is how you math. All right.